We'll solve another problem. Verify Green's theorem in the xy plane for single integral xy plus y square dx plus x square dy, where C is the boundary of the region given by y equal to x and y equal to x square. So there are two curves. Y equal to x is a straight line equation, whereas y equal to x squared is a parabola equation. See, parabola equation. Okay, so it's a parabola equation, and this equation is nothing but a straight line equation. So this is straight line equation, this is parabola equation. Okay, so this is your straight line equation, this is your parabola equation. Now look at the area bounded by the curve. So this is the area bounded by the curve. The curve is O to A to O, O to A to O. See here, O to A to O. Now we are going to use Green's theorem. As per the problem, and we compare Green's theorem, that will give you m equals xy plus y squared, and your n will be x squared. Okay, and dm by dy, differentiating with respect to y, m with respect to y will give you x plus 2y. Differentiating with n with respect to y, with respect to x will give you 2x. So we have obtained the value of this and this. As usual, first we will find out the limits, then we will go for the left hand side. So as usual, we will have to go for the left hand side. First we will find out the limits now. So it's given as y equal to x and y equals x squared. Y equal to x and y equals x squared. So if y equal to x squared, if y equal to x, substitute that will give you x equal to x squared. Simple one. Y equals x. So instead of y, you have to substitute x here. So x equals x squared. You bring this term to that side. So we have x squared minus x equal to 0. You pull x out. So x minus 1 equal to 0. Either x equal to 0 or x minus 1 equal to 0. So x can be equal to 0, or x minus 1 equal to 0 will give you x equal to 1. So we have two limits now for x, 0 and 1. If x equal to 0, y equal to 0, correct? X equal to 0, substitute in that equation. So y becomes 0. If x equal to 1, y will become 1. So there are two limits. We have 0, 0, 1, 1. So we have two limits. So this is for x and this is for y. Okay. So now this is for Green's theorem. These equations are given by this in the table, and we have, first we will calculate left hand side now. So left hand side is this one. Okay, we have left hand side. So we have now m dx plus n dy, and you just look at the graph. As I said earlier, it goes from 0 to a, then a to o, 0 to a to o. So we have now 0 to a, this is a to o. So we have now two curves. So one goes from 0 to a, another one is from a to o. So first we will go for 0 to a. So 0 to a will have a limit 0 to 1. See, 0 to 1, 0 to 1. So this will have a limit 0 to 1. So 0 to 1, what is m? M equals xy plus y squared, correct? N equals x squared, but it is given as y equal to x squared, correct? So m equals xy plus y squared, where m dx, we are calculating only a, o to a. This is your xy plus y squared, correct? And what is your y? Y equals x squared. So instead of y, you have to substitute x squared. So x into x squared, plus instead of y, you have to substitute x squared. So it becomes x to the power 4. Plus another one is n dy. N is given as x squared. What would be your dy? Dy is nothing but 2x dx. So x squared 2x dx. So x into x squared will give you x cube. Then this becomes x to the power 4, and this becomes 2x cube. So we have now 3x cube plus x to the power 4. On integration, you will have x to the power 4 by 4, x to the power 5 by 5. So substitute the limit now. When you are going to substitute the limit, that will give you 3 by 4, 1 by 5. Take the LCM. So that will give you 19 divided by 20. And this is for O2A. O2A. Is it okay? This is for O2A. O2A. O2A, the equation is y equal to x squared. We'll have to use only this. Now from A to O. A to O will give you this equation. So you have m equals xy plus y squared. What are equation? Y equal to x, we have to use y equal to x. Okay. So we have dy dx. So instead of dy, you have to substitute dx. Instead of y, you have to substitute x. So we have y, instead of y, you have to substitute x. Instead of y, you have to substitute x. That will give you this. So we have x squared, 2x squared, and this one x squared is there. So we have 3x squared dx. What is the limit? Limit is in the reverse way. So limit is in the reverse way. So this is 1 to 0. Don't forget. It goes from like this and comes down. So it goes from 0 to 1 and comes from 1 to 0. So we have 1 to 0. So 3x squared dx, integrating, that will give you x cube by 3. Substitute the upper limit will give you 0. Substitute the lower limit will give you minus 1. So we have found out now two single integrals. Okay. So we will have to add. So that will give you 19 by 20. See here 19 by 20. Next one is minus 1. Take the LCM, will give you minus 120, which is the answer for left hand side. Now we will have to calculate for the right hand side. Right hand side is nothing but the area enclosed by the curve. So we have now area enclosed by curve is given by this. So we have dn by dx minus dm by dy dx dy. So dm by dy is given by x plus 2y. dn by dx is nothing but 2x. So we have 2x. X plus 2y with a minus sign. So minus x minus 2y. dx dy. Is it okay? 2x minus x will give you x. So x minus 2y dx dy. It's given as y equals x squared. The limits for x will be, limits for y is 0 to 1. Limits for x will be y equal to x squared. So we have x equal to root y. This is one limit. Another limit is x equal to y. So we have two curves here. See, we have two. This is area enclosed by the curve. We will have to use both the equations. Earlier we used only one equation. Okay, because that one is line integral. Now this is area, double integral. Area enclosed by the curve. We will have to use two integrals. See, we will have to use two equations. One is y equal to x squared. Another one is x equals y. So this is a lower limit and this will be a upper limit. See, this will be a lower limit, this will be upper limit. So we have x minus 2y dx dy. So we have now just integrate with respect to x will give you x squared by 2. Here it is 2y x. Now substitute the lower limit and upper limit. So we are going to substitute the upper limit, that will give you x squared. Instead of x squared, you have to substitute root y. So that becomes root y whole squared will give you y. So y by 2 minus 2y root y. Substituting the lower limit will give you this. So we have minus, instead of x squared, you have to substitute the lower limit y. So that will give you y squared by 2 minus 2y squared dy. I have written the same thing here. Now y by 2, 2y, here y to the power 1 by 2. So y into y to the power 1 by 2 will give you y to the power 3 by 2. Is it okay? Simple. And here it is y squared by 2 minus 2y squared. Take the LCM. Will give you y squared minus 4y squared by 2. So that will give you minus 3y squared by 2. Already one minus is there. So we have plus. I repeat. See here, take the LCM. Y squared by 2 minus 2y squared. Take the LCM, that will give you y squared minus 4y squared divided by 2. So that will give you minus 3y squared by 2. Already one minus is there. So we have plus. So plus 3y squared by 2. So we have now 1 by 2. So integrating will give you y squared by 2 minus 2 y to the power 5 by 2 divided by 5 by 2, 3 by 2, y cube by 3. Substitute the upper limit first. So we have now y squared by 4 minus 2. This becomes 2 by 5 y to the power 5 by 2. 3 will cancel. We have 1 by 2, doesn't matter, 1 by 2. And substitute the upper limit will give you 1 by 4, here it is 2 2s are 4, so 4 by 5, this is 1 by 2. Take the LCM, will give you 5 minus 16 plus 10 divided by 20, which is nothing but minus 1 by 20. So which is the answer for the right hand side, which is equivalent to left hand side. So thus Green's theorem is verified. So any doubt? Now we will go for the next problem. Verify Green's theorem. Closed integral 2xy minus x square dx plus x plus y square dy, where C is a simple closed curve enclosed by the parabola y equal to x square and x equal to y square. Y equal to x square, y equal to x square, x equal to y square. So we have now two parabolas. Okay, so we have two parabolas. See, one is this parabola, another one is this parabola. See here, I repeat, y equal to x squared is one parabola, another one is x equal to y squared. So this is y equal to x squared, this is x equal to y squared, this is parabola. And what is the area enclosed? Area enclosed is this one. Okay, area enclosed is this one. Area enclosed is this one. And what of the curve? Curve goes from 0 to A, then A to O. Correct? The curve is 0 to A, then A to O. Y equal to x squared, x equal to y squared. So now x equal to y squared will give you substitute, that will give you x equal to x to the power 4. Correct? It's just a substitute. So we have now x equal to y squared. So x as it is like this, instead of y you substitute x squared. So that will be x to the power 4. Okay. So x to the power 4 minus x equal to 0. You pull x out. X out, that will give you x cube minus 1. Either x equal to 0 or x cube minus 1 equal to 0. So x equal to 1. Either x equal to 0 or x cube minus 1 equal to 0. So the x equal to 1. So we have x equal to 0 comma 1. If x equal to 0, y equal to 0. If x equal to 1, y becomes 1. So we have the limits 1 1 here. It is 0 0. Is it okay? Simple like. Now using Green's theorem. So it is given us along C1. So we are going to take x equal to y square dx. Just take this equation x equal to y square. Differentiating will give you dx equal to 2y dy. So this is for m and this is for n. So first we will go for the first integral C1. So C1 is n dx plus n dy. So we have now 2xy minus x square dx. So instead of y squared, instead of x you have to substitute y squared. So you have instead of x you have to substitute y squared. So this becomes y squared into y minus instead of x squared you have to substitute y squared. So y to the power 4. Your dx becomes 2y dy plus x plus y squared. Instead of x you have to substitute y squared. So y squared plus y squared, that will give you 2y squared. Simplifying will give you, here 2y is there. Okay, so 2 2s are 4. So 4 y cube, here it is y is there. So y to the power 4. Here y to the power 4 multiplied by y will give you minus 2y to the power 5. So easy to integrate with respect to y. So easy to integrate. So this becomes 4 y to the power 5 by 5, 1 2 0 minus 2 y to the power 6 by 6, 1 2 0 plus 2 y cube by 3. So substituting the upper limit will give you 0. Substitute the lower limit will give you minus 4 by 5 plus 1 by 3 minus 2 by 3. Taking the LCM will give you 17 by 15. So this is for C1. Okay, now we will go for C2. C2 is nothing but y equal to x squared. Y equal to x squared. So if y equal to x squared, dy equals 2x dy, and C2 m dx plus n dy becomes, now it is 0 to 1. Earlier 1 to 0. So it is 0 to 1. So we have now 2x, instead of y you have to substitute x squared. So 2x x squared minus x squared dx plus x plus instead of y squared you have to substitute x to the power 4. And what would your dy? Dy becomes 2x dx. So 2x dx. So simplifying will give you 2x cube minus x squared. Correct? This becomes 2x squared plus x to the power. No, you have 5. 2. See here one x is there. So we have x to the power 5. 2x to the power 5. So this one will give you plus x squared. So we have 2x cube plus x squared plus 2x to the power 5 dx. dx. Then integration. So on integration that will give you 2x to the power 4 by 4 with the limits 0 to 1, x cube by 3 with the limit 0 to 1 again. So we have 2x to the power 6 by 6. Substitute in the upper limit will give you this. Substitute in lower limit will give you 0. Taking the LCM will give you 7 by 6. And this is for C2. Value for the C2. Value for C1 already we have calculated. Minus 17 by 15. So you add these two. 7 by 6 minus 17 by 15 will give you 1 by 30. We have obtained the value of the left hand side. Now we have to calculate the area bounded by the curve, the right hand side. Area bounded by the curve, right hand side. So area bounded by the curve, right hand side. And of course we know according to the problem m is given by this, n is given by this. We need to have dn by dx and dm by dy. So just differentiate this with respect to y, differentiate this with respect to x will give you 2x and 1. Now we have substitute here, right hand side of Green's theorem will give you 1. See, this is 1, this is your 2x, so 1 minus 2x dx dy. What is the limit? Limit for x equal to 0 to 1. What is the limit? Limit for y. And of course it is given as C2 equals y x squared and C1 equal to x equals y squared. You will have to use both the limits because of the area bounded. So that becomes y equal to x squared to y equal to root x. This is for the second curve. This is for the first curve. Area for the area bounded by the curve, we have to use both the curves. So we have y equal to x squared to y equal to root x. 1 minus 2x dx dy. So first we will integrate with respect to y, that will give you, see y we have taken y. We have x squared to root x. And substitute for the upper limit will give you this. Substitute for the lower limit will give you this. Okay. Now we have, this is x to the power 1 by 2. Now multiply. 1 minus 2x multiplied by x to the power 1 by 2 minus x squared. We will have to multiply accordingly. So that will be x to the power 1 by 2 and this becomes minus x squared. Here it is minus 2x multiplied by x to the power 1 by 2 will give you minus 2x to the power 3 by 2. Minus 2x multiplied by minus x squared will give you plus x cube, 2x cube. So now x to the power 1 by 2 integrating, that will give you x to the power 3 by 2 divided by 3 by 2, x cube by 3, correct? We have 2 x to the power 5 by 2 divided by 5 by 2, x cube by, x cube is there, so x to the power 4 by 4. Okay. Now 3 by 2 I can bring it to the numerator, that will give you 2 by 3. Similarly 5 by 2 I can bring it to the numerator, will give you 2 by 5. 2 2s are 4, so minus 4 by 5. Substitute the upper limit will give you 2 by 3. Substitute the upper limit, that will give you minus 1 by 3. Substitute the upper limit will give you minus 4 by 5 and this becomes 1 by 2. Substitute the lower will give you 0. Taking the LCM will give you 1 by 30. So this is the answer for left hand side, and right hand side also answer is the same. Thus Green's theorem is true.